examples. Okay, so on this first one, it says, hey, I'm letting you know the derivative is this. The derivative is this, and derivative just means slope. And it says we also have this point, 0, 1. And they said write the equation of a tangent line at the point 0, 1. So let's start with that. AP is always going to give us 2 points for these questions. So we're going to do y minus 1 equals, we got to get our slope at that point, don't we? So what I would do maybe off to the side is I'm going to say the slope at that point is. And again, this is just one of those evaluation bars. And I'm going to plug in as x and a y, a 0 and a 1 for my x and my y in my slope. So we got a little 3 minus 1 times the cosine of 0. Hey, Bob, if I didn't want to take this any further, could I put this whole thing in for my slope? Sure can. Yeah. You know what I mean? If you're like, oh, unicircle and I aren't my top qualities, you guys, you could just write y minus 1 equals 3 minus 1 or 2 cosine of 0. That's your slope. You could do it that way. Times, what's my x minus what? X minus 0, right? Or you could just say x. So you could write it this way. Totes. If we want to get the actual value, what is the cosine? Whoops. Cosine of 0 is 1. 1 times 2 is 2, right? So my slope is 2. And then you could say x minus 0, or you could just say x, right?
Y minus 1 equals 2 of x.
Yeah, perfect. Then, so we just got a point for that. Use that equation to approximate f of 0.2. You guys, we know f of, this is always the x value. So now all we got to do is go plug that 0.2 into our function and get your y by itself. So I'm going to say, all right, my y is going to be about, because we're estimating, 2 times 0.2, and then I'm going to add that 1 over. Bob's going to be like this. All right, my y is going to be 2 times the cosine of 0 times 0.2 minus 0 plus 1. Either one of these, great. You could end there. You could end there. Or Cooper might say, but I know 2 times 0.2 is 0.4, so 0.4 plus 1 is going to get me 1.4.
Exactly.
Any of these are great. And at 0. 1 time. Okay, here we go. 2016. Okay. Lots of info. And again, you might have extra info because this is a free response question. And so we might not need it all. But it says we got temperature inside a refrigerator. And then what's dWdt referring to, do you think? Temperature inside a fridge, Celsius and hours. Yeah, the change in temperature, the rate that temperature is changing in degrees Celsius per hour, right? I dig it. dWdt is a rate. They said at T equals 0, the temp is 3. Is that a point? At T equals 0, the temp is 3. So I'm going to be like, ooh, that's interesting. 0, 3. That's just a point. Good to know. Write an equation for the line at the point where T is 0. Oh, snap. T is 0. I'm going to write that right there. I'm going to be like, okay, there's my point then. Use the equation to approximate the temperature inside the fridge when x is 0.4. All right, people. Let's go first. Write the equation of the tangent line at that point. To write the equation of a tangent line, we need a point. Got it. And a slope. Got it. What are we going to put into that slope? What do you think is my t or my w in this point? T is 0, exactly. T is going to be that time, always that x. I love that. So I might even write myself a little note. T is 0. Oh, yeah, they told us that, right? T is 0, so then my w is going to be 3. And I'm going to go plug that in to my dw dt. I'm going to say the slope at 0, 3 would be 3 cosine of 0 over 2w. Bob's leaving it here, so is Tatum. I'm here for it. Just as practice. What is cosine of 0 again? 1. 1 times 3. 3 over 6 is going to give me 1/2. That's my slope. Let's go write the equation of that tangent line. We'd say, instead of y here, because it's not x's and y's in this case, an AP will take off if we do x's and y's in the case when they give us different variables. So just like we know, it goes TW. X comma Y goes T then W. So it actually needs to be W minus 3. That's annoying. Equals my slope of 1/2, or Tatum and Bob are writing that whole thing for my slope. Totally good. And I can't write X minus. I got to write T minus. Do you have to do t minus 0? Could you just do t faux show? Faux show. So that's our tangent line. Boom, we got a point. Use that equation to approximate when t is 0.4. Just go plug it in. And I'm going to say W equals 1/2 of 0.4 plus my 3. And I'm done. Tatum is going to have a lot more than 1/2 written there.
Degrees Celsius.
Say that again.
2.2 degrees Celsius.
Oh yeah, I agree. 1/2 of 0.4 is 0.2. Very good. Very good. They're asking it in that way, guys. Let's do it because they asked it in a little different way. Grass clippings are placed in a bin. They decompose. Okay. The amount of grass clippings remaining in the bin is A of t. Is A of t a rate? It's just the amount. It's just a quantity. It's just a function, right? It's not a rate. It's not a dAdt or anything. Okay, the linear approximation to a at t equals 30 is a better model for the amount of grass clippings in the bin. Use that approximation to predict a time where there will be 0.5 pounds of grass clippings remaining in the bin. So we haven't done one quite like this. But first they want us to go ahead and find that linear approximation when t is 30. And we get a calculator. So we got to go write the equation of a tangent line when t is 30. So again, we've got big L and t. So just be careful. T is 30. We got to go find big L, which is going to be like my x and my y. How would I find my big L? I'm sorry, my big A, because they want us to use the linear approximation, but I got to use my A of t formula. So I'm going to say A of 30 would be how much? Could Bob say 6.687 times 0.931 to the 30th? That's my y coordinate. We could totally do that as opposed to like having to get the value. I'm going to get the value, and I think someone else is too. 6.687 times 0.931 to the 30th. Did you get 0.783, Kate? Perfect. 0.783. 0.783. Let me tell you what I just did there. They're saying the amount of grass clippings. We're saying on the 30th day, there is going to be 0.783 pounds of grass clippings in the bin. Can we go ahead and write the equation of a tangent line? Oh, wait, we only have a point. We got to get a slope. Let's go get that slope. Can I use my calculator to do that slope for me?
Good.
Yeah, if there's my A, and that's not a rate, let's go do math 8 and say, excuse me, can you please find that derivative? 6.687 times 0.931 to the x, and then we're going to say, I want you to evaluate that derivative when x is 30.
And we get negative 0.0559.
A prime of 30, negative 0.056, if I were to go 3 decimals. So let's go write the equation of that tangent line. That equation of that tangent line, if you're writing it with all the, if you're writing it like this, go for it, Tatum or Bob. I'm just going to write using these numbers since I have them. You guys, it would be A minus, we definitely have a T. Okay, but to your point, they said L of t, the linear approximation, so it's like they want us to do L in this case. But the tangent line, interesting. Use L of t to, yeah, let's go L. Let's go L. So we're going to say L, L minus 0.783 equals my slope, negative 0.056 times t minus 30. And if you guys jump to just getting that L by itself, good for you. I just always have to write it in point slope form first. So I'm going to say my linear approximation is going to be about negative 0.056.
Well, we need to figure out it's reversed. We need
Exactly.
T instead of L.
Exactly. He's saying, hold up. It says we need to predict the time where there will be 0.5 pounds of
already
grass
know
clippings.
L.
That's my L, isn't it? That is the amount. So I'm going to replace my L with 0.5. And to your point, we got to go find what T is. And thankfully, we got a calculator. So Bob or Tatum, this one could be annoying because we actually have to get the value, which again, you know what I mean? We're solving for T this time. So it might be easier to have actual numbers. So I'm going to take my 0.5. I'm going to subtract that 0.783. And I'd get negative 0.023 equals negative 0.056 T minus 30. I'm going to divide by negative 0.056, and I'm using those numbers from my calculator. So I'm going to just say divided by up arrow and get those actual values. And I'm at 5.054 equals T minus 30. And then I'm going to add 30 to it. And I'm going to get 35.054 because 3 decimals all day, every day. And I was about to say days, but I don't think that they asked for units, so I'm not going to. Predict a time where there will be half a pound of grass. So what's happening to this amount of grass is decomposing. So on the 30th day, I had 0.783 pounds. And on the 35th day, I had a half a pound. It's decomposing. Okay, we're going to do 5 part B, and then the next one, only part B. Here we go, because these are the 2 most recent tests. Consider this differential equation. Okay, we got a point. They say write the equation of the tangent line at that point. Well, guys, every free response question is worth 9 points. This right here is worth 2 of the 9. If you guys get a 40% on each, on the AP test, you've got a 3, okay? If you get a 40%, if you get 2 of the 9 points, 2 of the 9, you're already at 22%, okay? So of that question, yeah, but you can go get 3 or 4 points of every question. Boom, you've got it passed, okay? This is gonna be 2 of those points. Let's go get them. It is very doable, in my opinion. Write the equation of that tangent line. They gave us a slope up here. Well, they gave us a point over here. Let's go do it. Let's go find that slope, dy dx, at that point 1, 2. Bob, Tatum, sorry, I'm going to solve this guy. We got 1/2 sine of. My x is 1, y'all. So what am I going to put right here? Just pi over 2, right? Pi over 2 times 1 is just going to be pi over 2. Times root 9, or just a 3. I'm going to write just a 3. That's my slope. We could end there, but just some unit circle review is good. Sine of pi over 2. 1 times a half. A half times 3. 3 halves, very good. So then, can we use y and x's on this one? Yeah, buddy. Y minus 2 is my slope. X minus 1. My approximation when x is 0.8. We're going to say y is going to be about 3 halves. 0.8 minus 1. Throw that 2 on the other side. We are done. We're going to do 2023 just part B. And we're going to do the next one, just the first part as well. I don't care about the second part. Here we go. 2023. Wow, bottle of milk taken out the fridge, placed in a pan of hot water to be warmed.
You know, what happened?
So you guys, T is the number of minutes since the bottle was placed in the pan. Then we got the rate that bottle temperature is increasing or decreasing. Go find that tangent line, y'all. Y minus, not Y. M for Mesmer. M minus, what's that point? Did they give us the point? Oh, at T equals 0. So sometimes we got to dig, guys. At T equals 0, the temp was 5. Very good. So that's going to be 0, 5. And I also might write TM just as like my XY. Very good. So you're saying M minus 5 equals, we got to go find my slope. My slope at the point, 0, 5. My slope at the point, 0, 5. 1/4 times 40 minus 5. What's 40 minus 5? 35/4? Is that our slope?
It's about 10.25.
Yeah, I'm going to leave it as 35/4.
Oh, it's 8.7.
Oh,
What was I doing?
35 fourths. T minus 0, so can I just say T? And is 2 pretty close to 5? It's pretty close, so they're saying use that to estimate. M of 2 would be about 35 fourths times 2 plus 5. Done.